welcome to day 2 of solving LeetCode problems until I'm hired by a FANG company. Today we're going to be solving 1382 balance a binary search tree. Okay, so given the root of a binary search tree, returned a balanced binary search tree with the same node values. If there is more than one answer, return any of them. A binary search tree is balanced if the depth of the two subtrees of every node never differs by more than one, obviously. Okay, so example 1, we have a definitely not balanced binary search tree, and we would like to balance it in this way, right? Or this way. Isn't this like red black trees or something like that? So in this case, we could probably, I can't imagine myself using something like an array, right? In which we would just put in order all of our values here from the binary search tree. So we would have in order 1, 2, 3, and 4. And well, once we have this, we could just like create the first element and just make it the middle element, and then the left subtree is going to be everything that is to the left, and the right subtree is everything that is going to be to the right. So we had probably something even bigger, like if this was just a bigger binary search tree in which we would have 5, 6, 7, 8, 9. We would go to the middle element. So the middle element here would be 5. So we would make basically root 5 and basically node.left, whatever is created from this, node.right, whatever is created from that. So I believe that would work. So let's go ahead and try to create this. I believe we would definitely need to create a function that would allow us to just build tree, right? In which we would need an array, and this would return actually the current node, which would be here tree node, right? Nums, it's going to be a list of int. Right, and once we start doing this, we can do here if length of nums is less than 0, return none. We would actually need to have n is equal length of nums, right? So middle is going to be equal to n2, and we're going to create a brand new node, tree node, with val being nums at middle, right? Node equals the node dot left is going to be equal to build tree nums from left to the middle point, and then node dot right is going to be the same but to the right. And once we have this, we're simply just going to do here return node. That would be it for the build tree function, and then we would just need to create first of all the array, which we would just iterate through the binary search tree. And to do that, we would just need to have here array is equal to this, and we're going to do def first search. This way we would have our array. So we just here to call dfs root, and then we would just need to create return build tree of array. And I believe that would be it. I'm not sure if this is successfully going to work in our first attempt. Probably going to have some little bug or something. Unknown network error. That was very scary. So tree node list index out of range equals 0. Okay, so accepted both test cases. Let's see if it works for all of the test cases. Okay, it's taking a little while. Probably not very efficient unless my network is not having, okay, could be, okay, unknown network error. I believe that's better. Okay, so there it is. The algorithm beats around 48% and memory-wise 27%. We could probably just make it without the need of an array. But I mean, for a quick solution, this was definitely a very good one.